Like in the last video, we're going to make different kinds of atoms by putting 10 protons in the nucleus, one at a time. And as we do that, we will place 10 electrons in the electron shells outside the nucleus. Remember that we are simplifying our picture of the atom by not bothering about the neutrons at this stage. We'll do that later. We will also show how the atoms that we make fit into the periodic table. Let's see if there's a connection between the number of protons and electrons with the periodic table's shape. Adding one proton and one electron, as we already have, makes hydrogen, atomic number 1. As we add more, we build elements with bigger atomic numbers. After adding 10 protons and 10 electrons, we will have neon. Now let's start with a blank periodic table and add protons and electrons. See if you can spot the connection. Because we're only making the first 10 elements of the periodic table, we only need the first few rows. So let's zoom in on those. We'll start from the beginning by making hydrogen again. As we make the atoms on the left, we will put them into their position in the periodic table above. One proton and one electron makes a hydrogen atom, atomic number 1. Now watch the rest. Let's first look at where the protons in the nucleus show up on the periodic table. With one proton, we made the element with atomic number 1, hydrogen. With 2 protons in the nucleus, we made the element with atomic number 2, helium. There's a simple connection between these numbers. They're always the same. The atomic number of an element is equal to the number of protons in the nucleus. You can't get much simpler than that. Now let's look at where the electrons in their shells show up on the periodic table. Did you spot the connection between shells and rows? When we filled the first electron shell, we also filled the first row of the periodic table. The first shell takes 2 electrons before it becomes full, and the first row takes 2 elements. When we filled the second shell, we also filled the second row. The second shell takes 8 electrons before it becomes full, and the second row takes 8 elements. Can you guess how many electrons the third and fourth shells take before they become full? According to our new theory, the number of electrons that it takes to fill the third shell is the same as the number of elements in the third row of the periodic table. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. The third shell can take 8 electrons, same as the second shell. While we're at it, let's count the fourth row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18. So it must take 18 electrons to fill the fourth shell. Does this agree with the experiment? Yes, it does. Scientists have measured the number of electrons in each shell, and this agrees with our answers. 2 in the first shell, 8 in the second, 8 in the third, and 18 in the fourth shell. So how many electrons can the fifth, sixth, and seventh shells take? See if you can work it out. In the next video, we will see how the electrons in the outer shell are the most important ones. They tell the element how to behave. That is, what properties it will have, such as colour, hardness, electrical conductivity, and so on. They also tell the atom how it will join with other atoms, and how many to join with. The outer electrons are called the valence electrons, and they're really cool.